So in this lesson today, we're going to talk about adding and subtracting with complex numbers. We're going to talk about what part of a complex number is real, what part's imaginary, and how do we combine them. So that's what our cans are. I can identify and solve both the real and imaginary parts of the complex number. I can use the relation I squared equals -1 when necessary to add, subtract, and multiply complex numbers. Those are our I can statements for today, so that's what we should be able to do by the end of the lesson today. So a complex number is a number that can be written in the form a plus bi, where a and b are both real numbers, and I is equal to the square root of -1. The set of all real numbers is a subset of this set of complex numbers. So every complex number has a real part. If you notice here, the a is the real part, and an imaginary part, that's the b. Obviously, that's because it's attached to the I, and that's the imaginary part of even the imaginary part of the problem. So here we have some examples. Complex numbers are 3 plus 7i. The 3 is the real part, the 7i is the imaginary part. 3 plus 2/3 I, again 3 real part, 2/3 I, the imaginary part, and 4 minus I, again 4 real part, -I, the imaginary part. We've got a set of real numbers over here on the left, -1/2, 1.73, 0, pi, -9.6 repeating, and the square root of 2. Those are all real numbers. Then over here on the right, we have an I, we have a 3i, we have a -5i, and then we have the square root of -7. So my question to you would be, why is that an imaginary number? Hopefully you remember from yesterday that because that would be the square root of -1 times the square root of 7. So that would be I square root of 7. Okay, so when we do these part problems, example 1a says equating two complex numbers, find the value of x and y that make the equation 4x plus 10i equals 2 minus 4yi true. So we have the real parts that don't have the I attached to them. That would be the 4x and the 2. And then we have the imaginary parts, the 10i and the minus 4yi. We're going to talk about how we solve these types of problems. So what we're going to do is we're going to set the real parts equal to each other and solve for x, and we're going to set the imaginary parts equal to each other and solve for y. So when we do that, we've got 4x equals 2. So x equals, we're going to divide both sides by 4, 2 over 4, which is equal to 1/2 when we reduce it. Now when we talk about the y values, we've got 10i, again, because that's imaginary. We set that equal to that -4yi. Now, if we've got i's on both sides, hopefully y'all remember that they can cancel each other out because I can divide by both. So that means I've got 10 equals -4y. 10 equals -4y. I'm going to divide both sides by the -4. And when I do that, whoops, whoa. Jumped up for me. That's good. When I do that, then we get that y is equal to, if I divide 10 by -4, I get -2.5. Okay? So on the next set, what we're going to do is you guys are going to work a couple of these. Again, setting the real parts equal to the real parts and the imaginary parts equal to the imaginary parts. So you guys should be doing the U-tries 1 and 2. So number 1 is 2x minus 6i equals -8 plus 20y. So here again, we're going to do 2x equals -8. So x equals -8 divided by 2. So x equals -4. And then we're going to do our y values, right? So we're going to do -6i, imaginary to imaginary, equals 20yi. Again, what happens to the i's? They cancel each other out. So we're going to do y equals -6 divided by 20, which means y is equal to -3/10, which also you could get that as negative. Okay? Either one of those is correct. Then we're going to do our other one. This is number 2 over here. So this one was -8 plus 6yi is equal to 5x minus I square root of 6. Okay, once again, I'm going to set these equal to negative 8 is equal to 5x. X is equal to negative 8 over 5, right? Which would be negative 1.6 equals x. I'm going to do our y's, which are also going to be our imaginary. So we've got our 6yi is equal to negative I square root of 6. So what happens here, again, these cancel each other out, right? So we've got 6y is equal to negative square root of 6. So I'm going to divide both sides by 6. So our answer would be y is equal to negative square root of 6 over 6. So the next part of this lesson is where we're going to actually talk about adding and subtracting complex numbers. So if we have a plus bi plus c plus di, the real parts are a and c because they don't have the i's attached to them, and the imaginary parts are obviously b and d because they do have the i's attached to them. And we're going to add those together. So we would add a to c and we would add b to d. Same way with the difference, only this time we're subtracting. So we would subtract a from c, and then we would subtract b from d, or d from b, sorry. I said that backwards. C from a and d from b. Then also remember that complex numbers have additive inverses. So the additive inverse of a plus bi is minus a minus bi, right? Because when I subtract it, that's what it becomes. So now we're going to work a couple problems, y'all. So what I'm going to do when I do this is I'm just going to put in one set of parentheses, the real parts, and another set of parentheses, the imaginary parts. So I'm going to do 4. And I'm going to do plus a negative 6. And then I'm going to do plus my imaginary parts, 2i plus a negative 7i. Okay, so hopefully you know if you have a plus and a minus next to each other, we're really subtracting. So this is really going to be 4 minus 6, right? Which is going to be negative 2. And this over here is going to be 2i minus 7i. So that's going to be minus 5i. So again, put your imaginary parts together and your real parts together and combine those. Here's the next one. So once again, I'm going to do the same thing, guys. So we are going to do 5. This time only we're subtracting. So it's minus a minus 2, right? Okay. And we're going to add to that whatever we get for the next one. So now we're going to do a minus 2i, good, minus a minus 3i. Okay, so what you guys need to remember is when we're subtracting, when we subtract the negative, we change the sign, change what's behind. So that really means, what are we doing here? That means we're actually changing this to adding. So this is going to be 7, because 5 plus 2 is 7. Same way over here, change, right? So we're going to do negative 2i plus 3i. So that's actually just going to be I, because it's negative 2 plus 3, which is positive 1, right? So that's plus I. So what I would like you guys to do is do the next 4 problems, come back to me, and I will work them for you as well. Okay, so I'm going to put my 1 minus 1. Remember, we're adding a negative, so that really means we're subtracting, right? We got minus 3i plus 3i. So this is going to be 0, right? Plus 0, which is 0. The next one, negative 3. I don't have a real part of the other one, so I'm just going to say plus 0. And then, again, I'm going to do 5i. And I'm just going to put the minus 6i, which all of y'all should know that adding a negative is really subtracting. It's just going to be negative 3 minus I. Again, because 5 minus 6 is negative 1. Okay, let's scroll down to these other ones. So this time we don't have a real part in number 5, so I'm going to say 0 minus 3. And then I'm going to say plus my 2i minus my 5i. So that's going to be minus 3. And when I subtract the 5 from the 2, I get negative 3. So this is going to be minus 3i. All right, our last one. We've got 4 plus 4 plus 3i minus 3i. So this is going to be what? 8 plus 0, which is simply 8.